Hello, welcome back to my channel Study With Me. This time I will explain subtopics 1.1.1 about elements, compounds, and mixtures from structure 1.1 and the first themes models of the particulate nature of matter. Please join my WhatsApp and Telegram channels as I'm planning to create a dedicated IB chemistry community where we can have live classes, a place for you to post your IB questions, and I will work through them with you. Once we have a good number of students, I will officially launch the community. Please share these channels with friends who are also studying IB chemistry as well. The more students who join, the more opportunities we'll have to grow and support each other in our studies. Big Bang Theory. You always hear about this, right? So after the Big Bang, hydrogen and helium form, while other elements crucial to our surrounding were created in stars. This chapter delves into the differences among elements, compounds, and mixtures, explaining their properties through kinetic molecular theory and methods for separation. Understanding these distinctions is key in chemistry, as most substances in everyday life are mixtures. From these subtopics, you need to know how to distinguish between the properties of elements, compounds, and mixtures, separation techniques like solvation, filtration, recrystallization, evaporation, distillation, and paper chromatography also should be covered, and the differences between homogeneous and heterogeneous mixtures should be understood as well. So elements are the primary constituents of matter, which can't be chemically broken down into simpler substances. Compounds also consist of atoms of different elements chemically bonded together in a fixed ratio, and mixtures contain more than one element or compound in no fixed ratio, which are not chemically bonded and so can be separated by physical method. So this kind of method that we are going to cover in this subtopics. Matter classification. So let's talk about matter first. Matter is everywhere. We are made up of matter. We consume it, it surrounds us, and we can see and touch many forms of matter. Air is a form of matter that we know is there, though we can't see it. The universe is made of matter and chemistry. See how we can expand our understanding of matter and its properties? Matter and energy are closely associated with each other, and energy is often considered as a property of matter, such as the ability to perform work or produce heat. And in chemical reaction, the products have the same mass as starting materials, and the energy is transformed from one form to another rather than created or destroyed. Right, so matter, anything that occupies space and has a mass. It could be compound, it could be element, it could be your stuff like book, it could be your clothes, it could be anything. As long as it occupies space and mass, it's matter. Okay? Matter are classified into two: pure substances and mixture. Pure substances, it has a fixed composition by mass and fixed properties, cannot be separated into simpler substances by physical methods. Okay? But mixture, it has variable composition by mass, can be separated by physical methods into pure substances, and variable properties depending on its composition. And pure substance is divided to be two: element and compound. Right, element cannot be decomposed into simpler substances by chemical means. You can't compose magnesium to something that more simple than magnesium element or sulfur or any elements that you found on the periodic table. You can't separate them. You can't decompose them into simpler substances. And when Mg is combined with other elements, for example, oxygen and hydrogen, becomes magnesium hydroxide, right? So it's called compound. So compounds, two or more elements in a fixed ratio by mass, properties are very different from its elements. Mg, it has a different properties when it is as an element or when it is and it is different when it's already combined with other elements like oxygen and hydrogen, becomes magnesium hydroxide. All right, the same like sulfur. So sulfur as an element, it has a different properties when it is already combined with Mg for magnesium sulfite, right? So now let's talk about mixture. It is divided to be two categories: homogeneous and heterogeneous. So homogeneous have the same composition everywhere and components can't be distinguished. Like when you dissolve sugar into a water, you can't see sugar because it's already completely dissolved in the water. But homogeneous, it's like air. Heterogeneous don't have the same composition everywhere and components can be distinguished. For example, the smoke, it has pollution that has a dark color, and also it has air, oxygen, nitrogen. So you can actually see the difference between the mixture. All right, that's your understanding about the things that we just learned. So for number one, identify which of the following formulas represent atoms and which represent molecules. This one, obviously, atoms, and this one, molecules, okay, because O2, and this one is molecule, and this one, atom, because only one. And identify which of the following formulas represent elements and which represent compounds. Element, also this one, because it's just one type of atoms. And this one, also element, one type of atom, is just only oxygen. And this one, it's compound. And this one is element. Okay? Most everyday substances are mixtures, although they are often labeled as pure. Pure orange juice is a common example. The manufacturers simply mean that nothing has been added to the orange juice. In chemistry, the term pure is not used in the same way. In chemistry, what is meant by the term pure? It contains only one chemical substances, so that it means pure in chemistry. Why do components of a mixture retain their individual properties? Because they're not chemically bonded to each other. Unless they're chemically bonded to each other, like an ACl. An ACl is considered as the pure, as a compound, so it's not a mixture. But if they are not chemically bonded each other, it is a mixture. Group the following substances into elements, mixtures, and compounds. Right, so for mixture, that would be air, that would be sodium chloride solution, because sodium chloride is dissolved in the water. Sodium chloride crystal is a compound, because NaCl, they are chemically bonded to each other, right? And iron is the element. Chlorine gas is also element. Carbon dioxide gas, it's a compound. Okay? When a small amount of salt and water is mixed together, it forms a homogeneous mixture. But this is not true when flour is mixed with water. Why? Because flour is not soluble. You see that you can see that there is a flour in the water. So flour is not soluble, so there is more than one phase. Okay? Identify the correct descriptions about mixtures. The first one, the components can be elements or compounds. Second one, all components must be in the same state. The third one, the components retain their individual properties. So identify the correct descriptions about mixtures. The components can be element or compounds, correct. You know, elements, when they are combined forming alloy, it's a mixture of metals, for example stainless steel or brass. And compounds, when you dissolve an ACl in the water forming a solution. So in ACl it is a compound, right? And dissolve in the water forming a solution, which is a homogeneous mixtures. All components must be in the same state. No, an ACl is a solid and water is a liquid. The components retain their individual properties, yes, because they're not chemically bonded together. So they still retain their individual properties. So the answer is 1 and 3. Identify the homogeneous mixtures. There are gold, bronze, and steel. Steel and bronze are alloy. This one is an element, Au. So the answer is 2 and 3, C. Right, next one, separating techniques. They are filtration, evaporation, recrystallization, solvation, distillation, and paper chromatography. Let's talk about filtration first. So it's about a physical method that is used to separate an insoluble solid from liquid. Filtration is usually used to separate an insoluble solid from a liquid, but it can also be used to separate a solid from a gas. The solid left in the filter paper, for example, if you want to separate a mixture of sand and water, so that sand will left in the filter paper and it's called residue, okay? And the liquid that passed through the filter paper is called the filtrate or water when you want to separate a mixture of sand and water. And the filter paper acts as a physical barrier to the pieces of solid but allows the liquid to pass through gaps between fibers. So you just make sure that the size of sand is big enough, like the size is bigger compared to the pores of the filter paper. Otherwise, the sand will pass through the filter paper and you can't separate them. Next, evaporation and recrystallization. Okay. If a solution of sodium chloride is heated, water will evaporate or boil off to leave solid sodium chloride. So evaporation of the solvent can be used to obtain a solute from a solution. Solute is the crystal, salt crystal, and the solution, these salt solutions, right? If larger crystals are required, only some of the water should be boiled off, then the solution should be left to crystallize. Right, first, when you evaporate the water, there is no more water left, but be careful, you can't really heat up this for quite long until the crystal burns, but you just need to make sure that the water evaporates, all water evaporates, even though a little bit still left, but you can just leave it for a few days and this water will evaporate in a room temperature and you can collect the crystal. So that is the evaporation and recrystallization. So evaporation, the process to evaporate the water or the solvent. And recrystallization, we collect back the crystal of the solute that dissolved in the solvent forming solution by leaving it for a few days, because you can't really burn it for so long until you burn the crystal. Okay, even though a little bit water left, but you can leave it for a while and then leave it open and the water will evaporate by itself. For example, like this. So sugar solution, after you heat this up, okay, and now there is sugar right here, maybe a little bit of water here, and you leave it for a few days so the water will evaporate and only sugar is left. Next, solvation is a separate technique that is used to separate a mixture of two or more substances due to difference in solubility. So we've got two, CuO and NaCl. So this CuO and NaCl, they combine together and then dissolve in the water, right? And warm distilled water means that the NaCl will dissolve completely here in the water. So there will be, you can't see an ACl, but you can see the black color here. It's a CuO. CuO doesn't dissolve in the water. So now you filter them. So CuO will be filtrate, residue, and then an ACl becomes filtrate because it passed through the filter paper as a physical barrier, right? And now you repeat again the process of evaporation and recrystallization. So you heat the NaCl solution, so water will evaporate and you can collect NaCl. That is solvation. Next, distillation. Okay, so distillation is a separating technique that is used to separate miscible liquids with different boiling point. Miscible means that they combine. You can't differentiate them. So when ethanol is a transparent liquid, the same with water. So you can't see that the separation of ethanol and water in a distillation flask, right? But when you smell it, you know that there is something in it that is smell alcohol. So you know that there is ethanol inside. So now how you can differentiate, how you can separate them, okay? So we use distillation. So use the boiling points difference. Ethanol with the boiling point of around 78 degrees Celsius, and water is 100 degrees Celsius. So when you heat them up, you just need to make sure that this temperature, let's say, reach maximum 80 degrees Celsius, but nothing near to, no near to 100 degrees Celsius, because otherwise the water will evaporate and you can't separate them. So just to make sure that the temperature just above a little bit of the actual boiling point of the a liquid that you want to separate. So for example, ethanol that has the boiling point 78 degrees Celsius. So you just make sure that it doesn't go more than 80 degrees Celsius. That's why we put thermometer here. Then you heat them up, then ethanol liquid will evaporate and becomes gas, and we'll go through here, pass through condenser. Condenser is to cool down this gas, and it will become liquid again through condensation process, and we collect ethanol right here. Then ethanol and water is separated. Okay? Next, chromatography. Right, so chromatography is a separating technique that is used to separate and identify the components of a mixture. So the chromatography is used usually to identify the components of ink or pigments or amino acid, or to check whether this ink or this amino acid is pure or no, or is a mixture. So we can use chromatography. The amount of sample is very, very small. Okay, like a dot right here. All right. So we put it on the paper chromatography surface, the sample, okay? And then we put it inside a beaker or a container, and you need to cover with a lid because otherwise the solvent will evaporate. So we need to put it into the solvent. So the paper needs to touch the solvent, otherwise there won't be any separation. So as the solvent dries up the paper, it will pass over the sample spot, The components in the spot will distribute themselves between the two phases and so move out the paper at different speeds. They spread out according to the different solubilities in the mobile and stationary phases. Stationary phases is the paper chromatography, and then the mobile phases is the solvent. So when the solvent reach almost the top of the paper, its final position and its mark and is known as solvent front. Okay, so this is how you actually put the paper, and you can hang them with a thread here, right? And then cover with anything, as long as it should be covered properly so the solvent will not evaporate. Okay, and you just need to put like a dot, very, very small amount of mixture, a sample, and the paper is then placed in a chamber or container such as beaker containing small amount of solvent at the bottom. Placing a lid on the top to the beaker allows the atmosphere in the chamber to become saturated with the solvent vapor and prevents solvent loss through evaporation. So the components of the mixture move different distance, like in here, okay? And the different distances according to their relative affinities for the stationary and mobile phase. Component with the greater affinities for the solvent will dissolve more readily in it and are therefore transported further up the paper. So this one it has a greater affinity for the solvent, so it travels further up faster compared to the other elements. So these techniques also can be used to investigate mixture like leaf pigments or amino acid mixture, okay? And less polar dissolve in the solvent and get carried out further up the paper if the solvent is polar. So whereas more polar components stay predominantly in the water layer, so this separation can be optimized by using different solvents or mixture of solvents. So as we can see here, how do we differentiate between pure and mixture? So we've got red, orange, yellow, and purple. Look at to the red color. It has two different color. It means it is a mixture. This orange is just one color. It's a pure substance. And the yellow, it's pure substance. And the purple, obviously, it's a mixture because it has yellow and pink and also blue color. Right. So how you can do this experiment? First, you draw the pencil line. It can't be pen. It can't be ink, anything with ink. It should be pencil. Because if you draw it with anything with ink, for example, pen, then this will disturb your result because it will dissolve in the water. So pencil in the solvent, but pencil no. So you need to make sure you draw it with pencil. So place a sample on the line and let it dry. Suspend the paper in a solvent-filled container. Close the container to saturate the atmosphere. Then it will allow capillary action here, the paper, okay, to draw the solvent up the paper. Stop when the solvent front is 1 centimeter, not necessarily 1 centimeter, but it's not really close to up right here, because otherwise how are you going to check something that it's called RF value? This we will talk in another video because it's in another themes. And record the solvent front position with a pencil line and dry the paper. Right, so that's how you do the paper chromatography technique. These are the common separation techniques. So this is summarization of the separation techniques. So there is filtration, distillation, crystallization, and evaporation, paper chromatography, and separating funnel. So this when you want to separate immiscible liquids like oil and water. So physical differences in filtration, solubility, and distillation, boiling point, crystallization, and evaporation depend on the volatility, like the ability to evaporate, and paper chromatography of solution and recrystallization is solubility. So these are the example. These are the type of mixture. Right. So we talk about the difference of matter categorized as a two, pure and mixture, homogeneous and heterogeneous, and pure substances are elements and compounds. We also talk about the separation techniques like a filtration, distillation, crystallization, paper chromatography, solvation as well. Okay, so let's go back. Okay, so these are the several linking questions. What factors are considered in choosing a method to separate the components of a mixture? The choice of separation techniques depends on what is the mixture, what is in the mixture, and the physical and chemical properties of the substances present. It also depends on whether the substances to be separated are solid, liquid, and gases. For example, solid and liquid. So there are some uh, mixtures that are insoluble, solid is insoluble in the liquid, or soluble. So solid is soluble in the liquid. So you need to actually think the choice of the separation technique based on the physical and chemical properties of these substances present, right? Okay, so then how can the products of a reaction be purified? So if the desired product is a solid present in a large amount, it may be crystallized by slow cooling and then filtering from the solution and further purified by recrystallization. And maybe if the product is a soluble solid or a present in a small amount in a mixture, it may be possible to remove and purify it by chromatography, column chromatography. This one is not um, really like we don't talk about column chromatography. Okay, another example. If the products are immiscible liquids, they can be separated using a separating funnel like oil and water, or preferentially extracted into a specific liquid. Or also, if the desired product is a liquid, it may be removed by distillation. However, some organic liquids of high molar mass will decompose before reaching the boiling point. So we can use vacuum distillations. Involves carrying out the distillation at reduced pressure. This lowers the boiling points of liquids, making the process faster and reducing the risk of the composition. Next is, how do intermolecular forces influence the type of mixture that forms between two substances? By determining how strongly molecules of different substances interact with each other. For example, like solution, polar substances tend to dissolve in polar solvents, while nonpolar solvents dissolve in nonpolar solvents, like water dissolves salt, but it doesn't mix well with oil. Or suspensions, weak intermolecular forces cause the particles remain separated and eventually settle out over time, while strong intermolecular forces cause particles clump together and fall out suspension. Okay? And next, why are alloys generally considered to be mixtures even though they often contain metallic bonding? It is still a mixture. It's mixture between different elements. For example, you mix a aluminum, iron, and other metals to get the desired properties that you want. Like, for example, making machinery or frying pan that is made of the stainless steel. You know, stainless steel is a combination of different metals. So it is still considered as a mixture because it's combination of different elements that are not chemically bonded together. All right. So that's all for the sub units 1.1.1 about elements, compounds, and mixtures. Thank you so much for watching. If you haven't already, please subscribe to the channel and do not forget to share it with friends who might benefit. Be sure to join the WhatsApp and Telegram channels to stay updated on the community, where I plan to hold live classes, answer your questions, and work through IB style exam question for each topic. Your support means everything. See you in the next video.